Hello everyone. We're solving statics problems. Our topic, two-dimensional force systems. Our question, find the magnitude and direction of the resultant of the two forces, R, in the figure. Yes. We have two forces. Their magnitudes and directions are given, as is the angle between them. We are asked to find the magnitude and direction of the resultant of these two forces, the sum of these two forces. Now, we can directly find the magnitude of the resultant using the relation r squared equals f1 squared plus f2 squared plus 2f1 f2 cosine theta. This relation allows us to directly find the magnitude of the resultant of two forces whose magnitudes and angles are known. We substitute in the given values. We find the magnitude of R. By the way, this relation is similar to the law of cosines. However, there is one difference from the law of cosines: the sign in front of 2 is positive, not negative. We find R to be 872 Newton. Let's move on. Now it's time to find the direction of R. Let's find the direction of R. To find the direction of R, we need to draw a figure. I start the two forces from the beginning of the coordinate system. The lines of action meet and intersect there. After moving there, I draw a parallel from the tip of F1 to F2. From the tip of F2, I draw a parallel to F1, and a parallelogram is formed. The vector drawn from the origin of the forces to the opposite corner is the resultant vector. It is R. Yes. The resultant vector we obtain is shown in the figure. To find its direction, we consider one of the resulting triangles. In this triangle, we find the angle by using the sine theorem. We find the angle that the resultant makes with the y-axis. Let's call it alpha. Let's find the angle alpha. The side opposite to angle alpha is the same length as the force F2. The side opposite to 120 degree is also the resultant. It is equal to R, 872 Newton. We write the sine law. We find alpha, sine alpha divided by F2 is equal to sine 120 degree divided by R, alpha is equal to 36.6 degree. Thus, we found the direction of the resultant. Now, let's find the direction and magnitude of the resultant in terms of the rectangular components. The relations we will use are Rx equals total Fx, Ry equals total Fy, R squared equals Rx squared plus Ry squared, and tangent theta equals Ry divided by Rx. With the help of these relations, we will find the values we are looking for. First, let's find the x and y components of the resultant, the rectangular components. Let's find Rx. Let's find Rx from the relation Rx equals total Fx. We have two components. We will find Rx by summing their x components. Since the force F1 is perpendicular to x, it has no projection on x. Only F2 projects onto x, and it's in the positive direction. That's F2 cosine 30 degree. It's easily seen from the figure. So, we find Rx equals 520 Newton. Let's move on to Ry. We'll find Ry from Ry equals total Fy relation. We'll add the y components of the two forces and find Ry. The projection of F1 onto y is equal to itself and in the negative direction, minus F1. The projection of F2 onto y is also in the negative direction, minus F2 sine 30 degree. We substitute in the values. From here, we find Ry to be minus 700 Newton. After finding Rx and Ry, we can now find the magnitude and direction of the resultant. We find the magnitude using the Pythagorean formula. We find the direction using the tangent theta equals Ry divided by Rx. We find its angle. We find the angle it makes with the positive side of the x-axis. We see that the angle made by the positive side of the x-axis is negative. Because angle theta is a directional angle. When measured counterclockwise from the positive side of the x-axis it is positive. When measured clockwise it is negative. This angle is 53.4 degrees. The force R is a force in the fourth quadrant. We found that the angle made by the force R with the y-axis is 36.6 degrees. We can check this from here as well. It turns out that the sum of the absolute value of angle theta and angle alpha is 90 degrees. So, no problem. Goodbye.